All right, we're going to go ahead and get started. Thank you to everyone who is tuned into our webinar. We appreciate you taking time out of your busy days to join us about optimizing production management. I'm your moderator, Nick Azad, and I'm joined today by two of my fellow Parsec colleagues, Corey Vodbarka, our certified Six Sigma Master Black Belt, and Christopher Gray, our key applications engineer. To quickly bring you up to speed on who Parsec is, we've been in business for over 30 years with a dedicated focus exclusively on developing manufacturing operations management software, which you'll hear us abbreviate MOM. Our TrakSYS solution platform is designed to measurably help our customers without the need for disruption and major infrastructure overhaul. TrakSYS has been deployed in thousands of locations in over 100 different countries. We've helped customers in a variety of industries, food and beverage, pharmaceuticals, CPG, and aerospace, to name a few, to significantly improve their manufacturing operations. Today, we will be focusing on production management. Now, we reached out to a handful of our customers in advance of this webinar to get a gauge on common issues around production, as well as topics of interest. To address the information that we found, we will begin by discussing the challenges, follow that up with a demonstration of how TrakSYS helps solve the issues, and then end with an open Q&A session. So to kick things off, Corey, the first question I want to ask you, why would someone need advanced planning and scheduling software if they already have an ERP system?
Well, the simple answer is that most ERP systems plan using backward scheduling and infinite capacity. This means that it doesn't matter how loaded your plan is, your ERP system will actually create a schedule or a plan that says you can deliver everything on time, although you may have actually overloaded your work centers beyond their capacity. To deal with this, many manufacturers take the information from their ERP and they carry out scheduling in either spreadsheets that can be extremely massive or manual job scheduling boards. Mm-hmm. Either method requires gathering information like on-hand inventory levels, material on order, equipment availability, and employee schedules. This information is often spread into many disparate systems, making the process very administratively intensive. Mm-hmm. As companies increase SKUs and shift to shorter runs to reduce inventory and lead times, it not only adds complexity to the scheduling process, but it can also translate to lower productivity due to an increase in the number of changeovers. With an advanced planning and scheduling solution capable of connecting to a variety of business systems like ERP, MRP, WMS, and timekeeping systems where much of the information resides, scheduling activities can be greatly streamlined and result in reduced administrative load. In addition, the ability to apply algorithms for your scheduling rules allow you to quickly run scenarios that can be really determine things like the first available piece of equipment, so you can shorten your lead time for delivery. It can also determine things like the route with the best demonstrated performance, so you can maximize your productivity. It can also determine the job sequence that minimizes the number of changeovers. So applying these types of logic in your scheduling processes can actually improve resource utilization, increase productivity, reduce inventories, and expedite the decision-making process by allowing you to run different scenarios and accept the scenario that you like the best. This all translates into improved customer service levels.
Excellent. So with all that in mind, how can we make sure that we achieve a high level of schedule attainment and delivery performance?
So there's definitely many specific answers to this, but we'll start off with some real general best practices. The first thing is to establish standard operating procedures for how production activities are carried out. This helps to standardize best practices, establish time standards for how quickly work can be done, and assure consistent product quality so you have a reliable amount of material that is delivered during your production runs. The second is to make a schedule that accurately reflects the organization's capabilities. This will greatly increase your chance of actually attaining it. Use current and accurate demonstrated production rates and scrap or yield rates for your production planning process. Rates may actually differ by SKU, machine, and the route that it goes through, so those need to be taken into consideration. You should also take into account different types of changeovers that may exist in your operations. These can have different durations that need to be planned for accordingly. The next thing is, remember, if you don't measure it, you can't manage it. With ERP systems, they tend to be very transactional by nature. When the job is actually dropped to the production area, often it's not updated until the production run is complete. And this can create some very significant delays with tracking production progress and performance. By having real-time data from the shop floor automation and employee input, this enables management to quickly identify and respond to production exceptions, especially exceptions that may require changing the schedule on the fly. And the last part is to set up a process to log and categorize the root causes of unanticipated events and schedule changes. This allows you to really set a direction for continuous improvement efforts, so you can actually improve the scheduling process.
So the planning and scheduling function is highly reliant on inventory availability and accuracy, right? How does a MOM system improve inventory management?
Yeah, obviously you can't run a job if you don't have raw materials, and you know, the accuracy of your inventory can cause a lot of surprises when you go to run your jobs and the inventory is not available or the counts were off. So it's important to have it accurate and available. A MOM system can handle receiving inventory or importing that inventory information from a WMS system. This begins the process of tracking and tracing materials through the production life cycle. By having real-time tracking through all steps of the production life cycle, you can quickly identify stalled material movements and their locations. A MOM system can also leverage automation counters to quantify and categorize good inventory, as well as process scrap and defects. These are often a cause of inaccurate inventories. This consumption information can be synchronized with the ERP and the WMS system. This greatly improves system accuracy over backflushing inventory through the accounting and inventory system. You can also manage your cycle counting programs with a MOM system. This allows you to validate the accuracy of your inventory control processes. As well, you can automate the reordering and replenishment of inventory to make sure that things are available and on time.
Excellent. Well, thank you so much, Corey. I always appreciate getting to sit down with you and learn. So with what Corey just said, I want to now turn things over to Christopher Gray, who's going to take us through the TrakSYS application. Christopher?
Thank you very much, Nick. So before we actually hop into a demonstration, I am going to take you guys through a brief overview of the software, just to make sure that for anyone new to the software, we are all on the same page. So TrakSYS itself is an MOM platform that sits in the center of your operations and provides information from all the various disparate sources. So commonly, you're going to be using our software to be able to integrate to your automation via OPC and APIs to be able to get real-time data from your automation layer to determine how it's actually performing. In addition, we'll communicate with other things like various other business applications such as ERPs, COMS, as well as WMS systems to be able to provide additional context both from the system to us and from us back to those other systems. This is accomplished through our data management service, which uses things like standard APIs on either end, as well as web services to facilitate the communication. And lastly, of course, there is always the manual aspect to it and the ability to retrieve and report on the information. This is accomplished through web browsers that will allow operators and users to be able to go and access the information, make adjustments as necessary, and then report back on that information for analytics and trending. All this is provided through a web-based interface, so you're able to have all the information in the software in a real-time environment. You're able to access the information on any browser, on any device, whenever you need it. This allows you to take this information, be able to process information in real time, see your KPIs, see your downtime, see your scheduling, and see what's happening on your facility to be able to make improvements to your overall process. Now, in just a moment, I'm going to hop over into a demonstration environment where we can take a look at an example of what the TrakSYS software looks like when addressing a production management solution. Now, of course, if you do have any questions, feel free to ask them. There should be a way to ask it for the webinar, and we will be able to address them at the end of the demonstration. All right, let's hop over to here. We get to the correct screen and hide this, and we're good to go. So for this demonstration, I am going to be going through the various aspects of production management. I'll be focusing upon three main concepts: the ability to schedule production orders and be able to handle additional logic, the ability to execute those and view them, track the information, record the information, and contextualize it, and then the ability to report against that information in a number of different formats. To begin with, scheduling. When it comes to scheduling, or when it comes to production management, the first thing is you have to have jobs to be able to report against. So TrakSYS can allow you to take information from various sources to be able to go through the scheduling process. This can include simple setups like importing from an ERP system, or perhaps using an Excel spreadsheet. As Corey mentioned, there's likely some form of jobs that are available to us. We can take that information and turn them into process orders within our software. For example, in a more manual format, I may have a specific job listed that tells me what product I want to produce, how much I need to produce, and when I need it ordered and delivered by. Using basic logic, we can go through and take that and split it into a number of different components. In this example, we would have the ability to track it as a batch, tableting, and packaging job, and then be able to split it into specific days and quantities for you. Now, as Corey mentioned, there's a lot of aspects that go into the actual scheduling capabilities, not just the raw count of I need to produce X number at this time. There's sequencing that goes with it, having the jobs occur in the correct order, having the jobs occur in the correct order relative to other jobs, material constraints, and machinery and machine components that may need to be taken into account. With the TrakSYS software, you'll have access to things like a scheduling engine that will allow you to do things like import a list of jobs. So it might be from that Excel spreadsheet, as mentioned. Have those pop up on a list for you, so you see what you intend to produce, when, quantity, and even additional things like priority or other metrics you may want to use for evaluation. And then go through the scheduling process. In this example, we see a lot of various controls I can identify on the left over here. These are just example controls that you may use, but there is by no means an exhaustive list. This list does include things like planning efficiency factor, being able to say if I typically run at 100, maybe I want to say, assume I run at 80 to provide additional buffer in the event something goes wrong. The ability to identify if you can extend over scheduled time. Do you want to allow a job to start on Wednesday in the afternoon and finish on Thursday in the morning, or does it all have to be completed in one run before the end of the day? How do you want to handle priorities? By requested dates, your custom priority, or any other metric? And then how do you want to identify what is the most important aspects in scheduling? Getting them scheduled as soon as possible, reducing the amount of changeovers that you do, perhaps by theoretical rate that you run on the line, or a combination of those with things like tack time. Using the scheduling engine, you can provide all of these different controls. Simply go and select to reschedule, and then we'll go and process these one at a time. Now, this logic is going to be an example of our built-in logic, but as mentioned, true to the TrakSYS platform, you're able to add your own metrics and your own requirements with it as well. You can see here that my jobs have been successfully scheduled, and I have things going across all the way through the end of the week. In addition, if you need to see it, you can also visualize every single reason for why we scheduled it the way we did. We expose as much information as possible to ensure that you understand why it's being scheduled the way it was, and you can therefore make any necessary adjustments. From this point, you can then go and actually look at the scheduling and use it in that fashion and anywhere else in the software. I can take a look at my full plant overview, for example, and see all the packaging jobs that are coming up, including all the ones that were scheduled along my different lines as they, they're actually down here, as they got scheduled and stacked all together. Now, scheduling, of course, isn't going to be perfect for every single algorithm, so this will get you hopefully close enough And then, of course, you can make any manual adjustments and additions as necessary. After scheduling, the second part is actually being able to go and execute the process itself. So taking a look at this screen here, this is an example of a execution from the perspective of an operator on a discrete line. This will allow you to track the production run as it actually occurs, seeing information about it like when you have various downtimes, how you're producing, how far along you are in the production run, the ability to see various KPIs that go with it as well. Ideally, the majority of this would be collected through automation, but of course there's always a manual aspect. You can include things like manual events and stoppages, tasks for regular inputs and prompts to the operator, and journal information for additional context. To look at this in a little more detail, for example, tasks will allow you to go and provide regular inputs to an operator, saying every hour, every 2 hours, every 30 minutes, I want you to perform specific checks. And for all of these, you can provide pre-structured forms and formats to allow you to prompt them to provide specific information, provide them with the correct documentation instructions as necessary, and then also perform validations on things like weights and measures, providing min and max values, as well as the ability to dynamically determine what is considered to be accurate. All this information can be then utilized in the form of reporting later on, and you will be able to see that in a couple of minutes. We'll be able to take this information, have all of it contextualized specifically against the job record that was running, as well as a specific product, and be able to report those in a way that makes it more actionable after collection. This, of course, is not limited to just the discrete systems. It'll work for any type of process. So this is an example of a similar looking screen, formatted instead for a batch process. Same type of information is available, things like downtimes on your machine, and as well as how far along you are in the process, but it has a slightly different focus, where it's looking at things like specific steps of the process, as well as various critical parameters I may want to track. I'm able to look into these in more details, where I can see the entire full steps, each individual step of the process with its own set of instructions and reference documentation, as well as the ability to track the intended material consumptions, when I need to consume materials, how much I need to consume, and how I want to record it. As Corey mentioned, we have the ability to take this information and feed it back to other systems as well. So as I click on this ad, you're going to be able to see an example screen that shows you how you may go and collect the information. It might be something as manual and simple as simple inputs. I want to consume 1.3 is what it said, and it's lots A, B, C. Or you may incorporate automation in the form of simple barcode scans, scan it and get the lot. Freeway scans, where maybe we can scan it and evaluate it against another system or even ourselves to determine the lots and the quantity. Or an alternate screen, things like an entire freeway where the entire setup is based upon automation captures, where we have information about your warehouse and can determine what lots are available and potentially even enforce which lots you are allowed to consume, as well as capturing from scales, where a simple click from either our side or the scale can automatically input quantities for us to use for our capture purposes. Once all this information is collected, we can then go back and report against it easily. I can take this information and track my work in process, for example. As my batching process finishes, it can create the compound and automatically add that to my warehousing system. I can see those compounds in screens like this, where I have a list of all my agile that I've produced and all the different records that go with it. If I choose to track this information, it's going to allow me to go through and see not just the material itself and what I had, but all the consumption records associated with it, as well as anything that consumed it, giving me full access to the genealogy. I can see when it was first created, which would be created automatically, and I can see all the different times it had any types of transitions. From the consumption perspective, I can see when I made those freeways, I can see when I did those material adds, including the specific material consumed, the quantity, lots, location, user, and time. And I can also see when something consumed this material. So in this case, I'm looking at my work in process of Agile compound. That compound is intended to be created to tablets. I can see already that a good portion of it has been consumed by this specific tableting process here. An important note, as Corey mentioned, is that all this information can be fed back to the other systems in real time. So the information that I have on these screens isn't wrapped up and held in the system until the end of the day. It can be fed back immediately to provide accuracy and visibility into the system for your ERP system, for your WMS, and anything else that may be able to utilize it. Now, lastly, from a reporting perspective, Now that you've had all the information about your scheduling, now you've tracked all the production information, you need to be able to go back and look at those trends and determine what went well and what did not. On this weekly report of my planning, I'm looking at the last 7 days and how I performed. I can see that based on my schedule, I had a decent amount of on time and I did pretty well in full for what I expect. I can see the last couple of jobs. I can see where I had failure causes due to specific missing materials, which thankfully was not much. Alongside of that, I can see various other indicators on time by departments where line 3 seems to be struggling, but there's no indications of shifts. Plenty of ways where you can contextualize this information that you gather into a format that allows you to take a bit more action. Alongside of it, there are these schedule change logs. This is referencing the journals from one of the previous pages, where you can provide any additional records of context as necessary. Every time we make a schedule change, I can have a prompt to say, take the notes and create a log for it. Perhaps I go through and I run scheduling through our scheduling engine, but I find that after a week, I come back and there's a lot of log changes that all reference that they've made changes to reduce the amount of changeovers that have occurred. I can then go back and choose to reschedule or change how I use the algorithm based upon the input I've gotten from a screen like this. Alongside of it though, it's not just for the scheduling aspects. This can be accomplished for any number of different criteria. For example, OEE. In terms of your production run, perhaps this is a key metric to determine how well you're performing. This is a management screen based upon OEE to show you the current values where I'm having a very good run so far. I have the last 5 to determine some basic trending, and I can see things like failure causes. It also has its own set of performance logs, so I can see when there were red hours and what people are saying occurred to cause those red hours. I can see various other trendings and escalations of those manual inputs like tasks. So when a task fails or when a task is late, I can see it presented to me immediately. And as mentioned, this can be done in any format. So for one final example, there's also the ability to do it like a quality setup, essentially identical format, but different information. The quality information with quality rejects and quality trending, SPC information, but also the relevant tasks, and a different set of log entries that were recorded alongside of all my SPC collections. In total, you have the ability to go through the scheduling aspects, be able to take an entire list of jobs from any source you have, and apply logic, both our built-in standard logic, as well as any additional criteria you need. You have the ability to execute those on the various different lines, be able to track the information and provide contextualization, and then wrap all that up together into various reports that will have key indicators that tell you how you can improve your process. Corey?
Thank you for walking us through that demonstration, Chris. It was great to see how TrakSYS can be used to optimize many facets of production management. So we've just seen a piece of how TrakSYS can connect to a variety of data sources and allow you to seamlessly execute production operations activities. TrakSYS is a unified MOM platform capable of delivering a variety of manufacturing solutions. With that, we're going to jump into the Q&A portion of the webinar. Feel free to enter your questions into the GoToMeeting console. If there are any questions we don't get to, we will make sure that we answer all of the questions, as well as supply a recording of the webinar following the webinar. So let's take a look at the questions. The first one I have here is, does TrakSYS work with SAP? Chris, you want to?
Yeah, TrakSYS, one of the common integrations we'll do is with ERP systems, with SAP being one that occurs very commonly. We have a data management service that allows you to communicate with outside systems effectively through a number of different means. Now, every implementation does end up being different and depends a little more upon your specific facility and its network than it is the actual software themselves. But if you're able to allow us to communicate either through intermediary files, intermediary tables, direct SQL, web calls, web APIs, or they can use our APIs, then you have plenty of options to work with. So typically it will fall into one of those patterns, and there's plenty of examples of working with SAP that we can reference you to if necessary.
Thanks, Chris. The next question is, my standard procedures are in a document control system. Can TrakSYS connect to a document control system to use SOPs?
For SOPs, we do have the ability to have an internal library, so you can store some of them with us if you'd like, but it is very common as well for people to have entire sets of their own documents available, especially if you're doing versioning control. If you have access to it from the same network that TrakSYS is on, then you will be able to utilize them. If not, it's a similar fashion to working with the ERP system. You probably have an intermediary of some sort, but as long as you are able to expose the file, we can link to it very easily, typically through a direct hyperlink.
The next question is, can I switch languages easily within TrakSYS?
Yes, you can. So for the individual users, you're able to identify locales. By default, TrakSYS comes only with English, and then you're able to add on language packs as necessary. That way you only have the files that you need for your implementation. All standard screens and all standard parts of the pages themselves will translate automatically, and if there's anything specific to your implementation that you need to translate, there are configuration properties that will allow you to do so as well. So you're able to identify an individual user on the machine itself or on the browser what language you want to use, and it will display appropriately.
The next question is, what kind of changeover logic rules can TrakSYS deal with in terms of complexity?
So in terms of the changeover logic, there's a couple ways that it can be handled. The very first way is that you can provide a flat value before and after it for changeover. Now, most of the time that's not going to fulfill exactly what you need. There's a little bit more complexity that goes with it of changing from one type of product to another type, instead of saying that I always have a 30-minute changeover afterwards from my from product A. So in that case, we are able to instruct our own logic to provide any logic that you can identify for the changeover or for your changeover needs. So if you have multiple types of products, there's plenty of configuration that will allow you to identify those and then add that logic into the software. Essentially, everyone's changeover logic is a little bit different, so we provide a lot of tools to allow you to build that logic for you. But in most implementations, you're likely going to have something unique that will require some form of configuration of implementation-specific logic.
The next question is, in our process, throughput depends on product as well as equipment combinations. We have multiple mills that might perform differently for different products. Can the schedule engine deal with that?
Give me 1 second to read that a second time to make sure I got that correct. Yes, okay. So for each individual product, if you have machines that function the same, you can identify them using the same product set, which means they'll have the same exact properties. But each individual system can have a completely independent set of products or identical ones that just have different attributes. So essentially, short answer, yes, you can have different theoretical rates for every single product and equipment combination. This also includes other attributes, not just theoretical as well, just for reference.
All right. Well, we're going to go ahead and wrap things up. Thank you to everyone who wrote in and to everyone that joined us here today. As Corey mentioned, the answers to all the questions we received, not just the ones that we've covered, will be emailed out to you. For anything else, please feel free to contact us. And you can always learn more at our website, www.parsec-corp.com/TrakSYS. And again, there is that email to send any questions or comments to. Thank you so much. Till next time.